Hello and welcome to another reverse engineering video. In this one I will be talking about one of the challenges from Oh My Hack CTF. The challenge name is Flag Saver. It was solved by 20 teams and the description says, "We think one of our developers is hiding some secrets. Unfortunately, he's using secure screensaver, which makes a jigsaw from the screen. We managed to take a screenshot of the screen when he went to the toilet. We also have a copy of the screensaver, and of course we can get the files, and just so that we know, the flag format is flat and letter, digits and special characters." Okay, so I have the files on my disk, and if we extract them, what we are getting is this screensaver SCR and the screenshot PNG. We can open the screenshot, and as the description says, it's a jigsaw of potentially screen, which I guess we need to unjigsaw to get the flag. So basically the flag will be on this screenshot, and so we have to do it. And apart from the image, we are getting this screensaver program, which, for those who don't know, screensavers were used back in the days to save the screen. So basically, for the old monitors, if you weren't using the computer but it had to run, so the screensaver saved the screen by displaying some not so heavy intensive images. So usually it was something on the black background. So we have this file which is actually executable and we can run it. So maybe let's just do and see how it works. So I have a VM and I have those programs, and basically if we run without parameters, it will just ask for how many pieces we want to generate, but we can run it with S parameter, and then it will start with default settings. As we can see, it grabs the screenshot of this VM screen and just created a jigsaw of the screen. And as a regular screensaver, when we move the mouse, it stops working. So it exits to regular operation. Okay, so how we can approach this? Let's just save this VM so we don't need it anymore. And as I mentioned, it's a regular application, and in this case it's actually .NET application, so we can use dnspy to inspect of this file, and I have it loaded in dnspy. So basically it's a regular .NET application, and we can see that the entry point is screensaver program main, which we can just go to. And basically at first there are those parameter parsing. As I mentioned, there are some parameters supported, like C, P and S, which I used, and basically they do something additional, but more or less at the end they run this screensaver program.screensaver. And if we go here, it actually collects all of our screen and passes the bounds to the screensaver form, which basically in the VM, I guess there's one screen, but if you run it on multiple screens, it will generate the screensaver on all of the screens. So let's just go inside this screensaver form, and basically we end up here, which is the main window of the application. Of course, in this constructor doesn't happen much, but if we scroll through this code, and there is this screensaver form load method, which actually, I guess it's a hookup to the load event. Of course, we could check it by inspecting more code here, but basically we can assume that this is what's happening when the main window of the application loads. And what we can see here, there is some timer being set For 3 seconds we have the timer tick event and the timer is started. And on the tick event, what is being done, which actually we could see from running the application. So basically the layout of those puzzles changes every like 3 seconds, I guess, based on the code that we see here. So basically when we keep running the application, it will generate randomly different layouts of the jigsaw. But let's go back and see what we have more in the load event. So there is this take screenshot method, which I guess grabs the graphics of the screen and returns it, and we get a bitmap object. Okay, we save some width and height of the captured image. We have mouse click and mouse move events, so basically we capture those to exit when user either moves the mouse or just clicks on the anywhere, I guess. And we add this image control. So I guess what we see on the screen is just an image control. I guess the window is not visible. It's like it has hidden all the stuff that usually Windows has. We can only see this image control which displays this jigsaw puzzle. Okay, so let's get back to this tick event, which basically does all the job. So it takes the screenshot, the captured screenshot. It just generates how big the pieces will be. So basically we have the base width and base height, which is basically in this case how big the screen is. It uses the base here, so basically it takes the control, but the control is full screen here, so basically it is the width and height of the screen, and divides by pieces. So basically it has by default 40 pieces generated, so it will divide our screen resolution by 40 to get how big and how tall the pieces will be. And we generate some array of images, and then we go over set so many pieces and generate parts of this captured image. So basically we extract smaller rectangular parts of the bitmap and save it into this array. Then we call shuffle array, which basically does all the shuffling and basically rearranges the pieces, and we return the shuffled image array. We'll get back to this method in a moment. And then we construct a new image from those randomly sorted, or not sorted, but randomly reordered pieces, and then we just display this new generated image. So as we can see, the most important part is this shuffle array. Basically it takes parts of the image, the original image, and returns shuffled array of those elements. And how does it do it? It uses this LCG class, which I guess stands from linear congruent generator, which is like pseudo-random generator class that generates pseudo-random numbers. And basically it is initialized with some values and then goes through defined pieces and just select randomly a piece and exchange it. So basically we select one number and another number, and pieces at those indexes are being swapped together. And that's the whole idea of this shuffling. And what makes this shuffling, let's call it random, is this LCG class. So in each call to shuffle array, we will get a new LCG, which is initialized with, for now, unknown value, and 65537, which is I think in this case it's modulus. So basically we will get not bigger number than this value, but of course we'll also limit later to the how many images we have in this array. So basically we get a reminder of dividing by num, which is like pieces squared. So how can we know what are the values being generated by this LCG? Because basically the idea is to get the numbers to see what was the change done by this program and then reverse it. So here we know the modulus, but we don't know what is this value. But if we go to the field, we actually see what are the values being initialized, used here for initialization. So it's 51966 and modulus is 128. So we have the values that are being used for the initial initialization of this pseudorandom generator class. There is still one unknown, or maybe not unknown, but it might be good to know one more thing, which is not obvious from looking at the screen, or maybe it is. At least it was for me. So by default, the pieces is being set to 40. But if we look at this image, it's for sure more than 40 those smaller pieces in row and in column. So basically we need to know how many of them we have, because otherwise we won't be able to correctly decode this image. And we can know it but by just checking the image dimensions and seeing how big or how small one of those square, or not square, but rectangular pieces are. And we can see there are some that are really easily distinguishable from the others, so we can just measure in one of any graphic application to get the dimensions of those small squares and get the dimension. And actually it was 120 pieces generated, so that's the correct value for pieces if we want to solve this challenge. And to solve it, I wrote a simple C# application. Since the challenge was in C#, I wrote the solver also in C#. And basically the solver is greatly reusing the code from the original application. So we have this LCG. We have method solve, which actually is in most part the code from the tick event that we saw in here. So basically this is the tick event, and the code for the solution is also similar. There are a few changes which I will describe in a moment. So my idea for solving this was, since I know all the values for this pseudo-random generator, I will generate the numbers, perform the shuffling, and then I will go from the end and reverse basically the changes being done by the shuffling. What I didn't know at first is whether this program was running for a long time, and how many of the iteration happened, because it could be that if the program was running for a long time, it could shuffle many times, but basically, as we will find out in a moment, that wasn't the case. So I wrote this generate array method, which takes the ticks, basically how many I want to run the generation of the array. And I start with an array of numbers from 0 to pieces squared. So basically I have array of sorted numbers, because basically that's represent the original image. So in original image, the squares are in order and then they are being shuffled. And so this is my starting point, and then I have the same code, but instead of shuffling images, I just shuffle the numbers in this array. And at the end, yeah, I got some printing here and just return this array as an output of this method. So basically from this method I have a shuffling of the pieces as an array of what is a list of tuple. So basically list of tuple of 2 ints. So having this move list, then I have a code that is similar to the original one with one change, which is I created another array of images called copy here. So basically I figured that if I'm doing the reverse process, it might be that some of the images will be overwritten at the point that I don't want it to happen. And I think when I was testing, I got some artifacts. So basically this copy of an original array is to make sure that if I'm placing an image, it's correct one. So basically I have a correct copy of this small rectangular part, and that's the only change in this part. Then we have the shuffle array, which is changed by me by passing this list of moves that being performed, and then I construct the big image from those from this array, and then just display, and I'm just saving to the file. So basically if I happen not to, like for some reason the application will crash after displaying correct image, I will have it saved so I don't have to do it again. So the shuffle array, how it's being changed, it's a copy of the, well, it was copy of the original method, which is I guess here, which exchange images. I tried to exchange also, here's the numbers in the array that I've got, but there was some issues with that, so I didn't do it. So basically I'm just taking the change from this move list and just get the correct image from the copy and put it in the new array that I'm constructing. So in this image array I get the image from the copy and just put it on the place based on the move list that I was getting from running the pseudo-random generator. And at the end, this is just a comment, returning this image array. There was some tries I had before I actually managed to get this to work. And I guess that's all. That's all. When we run it, it will, as mentioned, generate the moves. It will split the image that was jigsaw into those small rectangular parts. Then it will reverse the shuffling, construct the big image and display it and save to the file. Hopefully we will be able to get the flag by doing so. So let's just see how it works. It's just a simple WinForm application, so we have a nice form with nice names on it. If I press solve, it actually executes the method, and I hope I don't have any breakpoints. So basically this is the first image that we get, and in a moment we should get the image decoded. It takes some time because those graphic operations are not really performing well. I guess it could be optimized, but it doesn't matter. So we got the image decoded. I have it saved on the disk. So let's just go to the solver. In debug.NET Core, there's so many folders, and this is solve1. So basically that was the original image that was shuffled, and we got the file from the challenge, and we can see here the flag is flat. Screensaver is not a good flag saver. And I think this is the code from the task. So basically there was a flag at some point, but of course it was, I guess, removed from the final challenge because that would be too easy. But yeah, that was all to get the flag for the flag saver challenge. It was quite nice challenge. And yeah, as I mentioned, I had some issues with reconstructing the reverse shuffling operation, so it took more time than I wanted. I got some testing done with some smaller pictures to get basically the idea if my decoding works, but finally I managed to do it and decode the shuffled image. So yeah, I guess that's all for this challenge. I hope you like it, and if so, please like and subscribe, and see you in the next video. Bye bye.